Good afternoon. My name is Leanne Melbourne and I am the Events and Communications Manager here at the Linnaean Society. Firstly, a bit of housekeeping. We don't expect fire alarms to go off, but if they do, we need to exit the way we came through the front doors and wait in Burlington Arcade, so we can just make sure everyone's out the building. So today we've got an extra special lunchtime lecture. We have Dr. Mark Nelson, Sir Ian Prance, talking today about lessons learned from Biosphere 2, the world's first experimental laboratory for global ecology. So I'm going to introduce Sir Ian Prance first, and then he'll speak, and then Sir Ian will introduce Mark afterwards. So Sir Ian Prance, who is the past president of the Society here, he was president between 1997 and 2000. He has conducted 39 expeditions to study the Amazon flora, and is former director of the Royal Botanical Gardens Kew. So Sir Ian, thank you.
Thank you for that introduction, and it's always good to be in the Linnaean Society. As you heard, I was president, and I know one of the things we did while I was get Alfred Russel Wallace up beside Darwin.
Yes.
We needed to give him a place. Right, we're going to talk about Biosphere 2. Between Tucson and Phoenix is Oracle, Arizona, and it is here that one of the great experiments, I'm just going to see, oh, maybe I can do it on the computer, right. One of the great experiments of all time took place, the building of Biosphere 2. Here are some statistics about it. I have been working to various conferences with the Institute of Ecotechnics, and so they knew my interest in the rainforests and their preservation, and so this is divided into various biomes, and so I was asked to help design the rainforest. That was really exciting invitation, and I had met Mark Nelson quite a while before that at the various conferences, and so Mark is an old friend, and I'm delighted that he's here and we're working together on this. So Mark, as you can see, is on the right-hand side of this photo, and the gentleman in a hat is John Allen, who is really a Renaissance man, and I think he was the instigator behind all this. But not only that, he was the ideas man and stimulated so many of the things that turned out to be Biosphere 2, and always gave us encouragement as we worked on this. Recently there have been 2 books about Biosphere 2. It's 25 years since the people who went in, the first 8 people that were in this sealed environment for 2 years, came out. And so it's time to look back a bit on it. And we really, one by John Allen, and the other one is Mark Nelson's book, Pushing Our Limits, and I recommend you read it because it's a very honest book about it. It talks about this visionary project, but it also talks about the things that went wrong as well. And it's a scientific experiment, and I think you learn just as much from the things that don't work as do. The press pick up those, of course, and not the good news. And as I look back on it, I see it has achieved so many things and been used a great deal. So here it is being built, and I brought many of my colleagues to Arizona to help me, because building this rainforest I needed various assistants. So here are 2 of my graduate students who are working with me at New York Botanical Garden. Andrew Henderson, who is an expert on palms, and the other one is an expert, so he was doing his thesis on peanuts, on arachis, and so he was talking about food plants and was very useful with ideas. Because when we built this rainforest, and knowing that 8 people were going to be sealed in there for 2 years, we wanted the rainforest too to have 1 or 2 things that could be harvested and help, because they had a small and very efficient farm that Mark will tell you about. But it was good that there were a few luxuries in some of the other biomes. And then I had John Lonsdale from Kew there, who came out and was very helpful, a member of the Living Collections team at Kew. So I borrowed colleagues, former colleagues at New York and colleagues at Kew as we were putting things together to get the rainforest right. And we had so many different meetings, informal ones, just chatting outside, meetings in the various offices to talk about it. On the extreme right there is the person who was a captain of the savanna biome that was in there. It had a savanna, a rainforest, and an ocean, and of course a farm. So here we have some important people with it. Mark Nelson, who is one of the biospherians. He spent 2 years shut in there, and this book is about that experience of being there, but it goes far beyond that and puts the whole thing very much into context. And in front here, taking notes about things, is Linda Lee. She was one of the other biospherians, and she had good training in botany, and it was with her that I worked a lot on collecting the plants, discussing what to put into the rainforest and the other biomes, and acquiring plants to put it in. So she worked with it for 2 years before, and so was very well equipped by the time she went into the biosphere. One of the criticisms that the press picked up, if you're doing this as a scientific experiment, why haven't you put scientists in there, PhDs? Well, I tell you, if you put 8 PhDs together there, it would just not have worked. These were generalists who could repair the mechanisms of everything that was in there, who could farm so that they could feed themselves and everything like that. And all of them were remarkable people because between them they had so many skills, and they showed that they could create a biosphere. Well, it was a wonderful experience trying to get things into the rainforest. And one of the important things was to make it look a bit like a rainforest right at the start. So I had to think about what grows quickly and start a succession. So I used some of the plants that are light demanding in the rainforest that grow up quickly. And I had seen in the north of Argentina a species of Phytolacca that grew very, very quickly. Interestingly, we think of Phytolacca as a herb, but there's a tree species. So I collected some seeds of that, and it very soon grew and grew. It was a wonderful thing, giving the aspect of a rainforest. The other thing we tried to do was put in different habitats. There was an area that flooded, emulating the Varzea forest of the Amazon, and there was a mountain emulating the tepuis of the Guyana highland. And in that we put various plants, and there was a nice area for the biospheres to relax up on the top of the tepui. One of the important things is that in each of the biomes everything was mapped, because this was a scientific experiment to see how things were doing and how they were developing. And so we began with good maps of what was in the rainforest biome. You notice on that chart everything is numbered, and that corresponded with a database on the plants that we kept. And the biospherians, while they were there, recorded a great deal of information about what was going on in there. And you see on the left-hand side, we tried to produce mist like a cloud forest, make it a real cloud forest, like the tepuis are inside, and that worked reasonably well. Now, one of the things I knew, because I've been working with a project on minimum critical size of ecosystems near to Manaus, Brazil, where we isolated different areas. And the small areas of 1 hectare or 10 hectares, there was a terribly strong effect coming in from the edge, an edge effect, well known in ecology. And so if you've got a small rainforest here, I thought of all the light coming in and doing the same sort of thing. So what we did was plant various bananas and members of the Zingiberales around there as a light barrier to stop the light coming in. Then over this was the ocean, and we didn't want too much influence of the ocean coming into the rainforest, so there we built a bamboo curtain, and it too worked quite well to keep them apart. So that was all part of designing. There is the ocean, by the way. And in this one you can see around the edge all these Zingiberales. Some of them were just there to shade, others ornamental like heliconias, but there were some bananas there, and I hope you harvested some of them, Mark, because that was the idea of that bell.
Well, we left others for the galagos.
Ah yes, that's right. Mark will tell you more about it, but look at, it's a magnificent construction with all these biomes in, and it was so exciting to be part of it. Look at the work that went into designing and the architecture and all that, and because we were responsible for building a rainforest and the other captains for other things, we talked a lot to the engineers. We want this, and very often they wanted something else. But I think, on the whole, the biologists won out in getting the designs that they wanted in the different parts. So here it is in the evening, and you see that bulge on the left-hand side. With the changes of temperature between night and day in Arizona, the air inside expands or contracts. And so you have to have an area that can form a lung at the side. So in fact it had 2 of these on it, and that way it coped with this changing volume of the air inside. So all these little items were thought of in the design of it. So that's my association with Biosphere 2. It was wonderful over that time, and I went back to see the biospheres through the window, discussing problems with Linda Lee about plants that were not doing right by telephone, as they did of communication with the outside world, and that sort of thing, so it went on. But it wasn't long after that Tim Smith came and saw me and said, would you help with the Eden Project, because I hear you're a rainforest specialist. And so I did, and I tell you, the lessons learned from Biosphere 2 came in so useful for that rainforest at Eden. There are different sort of project. Biosphere 2 was sealed so that it was almost airtight. The Eden Project was deliberately open to be something for the public to come and learn the importance of plants to people, basically. But as I designed their rainforest, I thought of what worked and what didn't work in Biosphere. We had various problems with the soil, for instance, in Biosphere 2, in the rainforest. And I said to the Eden Project right at the beginning, we must have a soil specialist. And I was like a broken record at all the meetings of planning. We need a soil specialist. And so ultimately they hired Tony Kendall, the soil lecturer at Reading University. And he was invaluable because the soils in all the biomes at Eden work extremely well because they were designed by someone who knew a lot about soils. It was very important that we did that. So here is just a view of the rainforest in Eden, learned from Biosphere 2, and some people enjoying it. The children's program there is extremely important. Well, now, having done those two, I thought I had finished this sort of thing with ambitious, wonderful projects. But no, I am chairman of an NGO called MEMO, Mass Extinction Memorial Observatory, and we are taking over some caves in Portland Island that have been carved out to get Portland stone. And we formed a partnership between the Eden Project and the Stone Project. As they take out the stone, we're taking over to have a wonderful exhibit of biodiversity and the importance of biodiversity using stone carvings of extinct species, but also using the most modern projection techniques, laser and things, so that people can get into the rainforest in a three-dimensional way without there being any trees at all. I see how well this works in the Museum for Tomorrow in Rio de Janeiro, so I have no doubt that we can give a wonderful experience on this. So now I'm very busy working on this and currently trying to raise a lot of money to open Eden Project Portland. So that's, you saw a carving in the last one of an extinct species of Cyanea superba, but it's an important endemic genus to Hawaii. Those are the sorts of things we are trying to do there. So Biosphere 2 has led me into all sorts of things, and many of the people who were involved with Biosphere 2 have applied what they learned in other places. I think that's one of the most important lessons from Biosphere 2. And now we must hear from one of the biospherians, Mark Nelson. You see his book up here, and I think there are some copies here if you want to get one. I highly recommend it. Mark, after he went through Biosphere 2, did a PhD with the Odum brothers, two of the most famous ecologists you could imagine. So he too, it led him into pursuing much more than just farming in Australia to a career in ecology, and particularly in wastewater management too. So Mark, over to you.
Difference between US driving and British driving. So do we need to switch slideshows? So, you know, I'm glad we have a bit more time because I want to give you kind of the full and the backstory of Biosphere 2, because it's often kind of seen as something that just sort of suddenly happened in the Arizona desert. But the story is quite more complex and interesting than that. So I want to give you some of the background of the creative team who basically conceived and managed and put together the project, and also some of the historical scientific traditions that kind of make Biosphere 2 in context more understandable. So I need to start with Institute of Ecotechnics, and the basic story I want to tell you is that starting in the late 1960s, we formalized the Institute in '73. It's now in the US and the UK. We could see very clearly this very troubling aspect or almost dominant feature of humanity's relationship with the biosphere is that the technologies that we've chosen really don't harmonize with the biosphere. Unintended consequences, you can call it. Oh, I'm sorry. Did everyone hear that? Well, I'm not going to repeat that. So let me walk you through some of the projects. And we started in New Mexico, and kind of, you know, I'm a New York City kid. I went to university in New England. I'd never seen anything as bare and semi-arid or arid as this part of New Mexico. And unfortunately, it was a good illustration. This is actually much worse ecology than it was before first the Spanish and the Anglos came with their cattle and overgrazing and inappropriate farming. So this is a highly degraded ecology that happened in the last century. And our goal was to see if we could make an oasis in the desert. And if you know some of the books in ecology, there's been a very powerful story, a very unfortunate story, that civilizations tend to leave deserts in their wake. So we wanted to push the envelope and push the ball up the hill, little Sisyphean action. But to use the best of, as Ian was saying, we're not primarily academic scientists, but our starting point was that we know enough about ecology that we can change business as usual if you make the intention that all the technology that you're going to use is appropriate, and your goal is both to meet human needs and to upgrade, restore the ecology, the local ecosystem that you're in. And after about 10 years in New Mexico, the city boy became a practical both farmer and tree planter. I went to Australia, and we have a project in the Kimberley region, and what was really interesting to me was in the tropical savanna, as opposed to the high desert, semi-arid grassland, the same story. And even in a quicker time, because the Europeans, the Australians, didn't get to a lot of the outback until maybe the late 1880s or so, but devastation ensued. And this land was so poor that the Australian government said, if you can improve it, and they were interested in improving it because this is typical of millions and millions, maybe tens of millions of hectares, we'll sell it to you for $1.60 an acre. But the catch was we had to figure out how to restore the pastures and upgrade the ecology again. And then over the years, education outreach is really important. This is an interesting area because not only is it very, very remote, 2,500 miles from Perth and 1,500 miles from Darwin, heavily Aboriginal. And so our programs, which were, in general in ecotechnics, our motto is learn by doing, involving Aboriginal kids with learning to ride horses, take care of cattle. Aboriginal culture has a rich tradition of caring for the land. We actually could get motivation and really good success rates that usually fail with Western educational types, and a little view of the pastoral oasis that has ensued. And all our projects, all of these land projects, by the way, we always reserve some of the land to be basically untouched as a long-term control. So that's true in Australia. Then, and again, Sir Ian has given you a little preview of Biosphere 2. And key to it, of course, anyone who reads ecology and understands the Earth, is the building blocks of biospheres are biomes. So the program of the Institute of Ecotechnics, which is a small institute in terms of numbers of people, but with fairly large, ambitious ideas that we have great fun in implementing, was that we need to train our people into a representative section of biomes around the world. And we tend to choose ones that conventional approaches, conventional ecological approaches, especially conventional economic approaches, have proved to be inadequate. So we found a rainforest project in Puerto Rico, and it was it's secondary rainforest. It was heavily logged. It was, most of the land was converted to coffee plantation. And the idea there is sustainable forestry in the rainforest. And so in cooperation with the Puerto Rican government, we planted 40,000 seedlings of valuable native and suitable hardwood species with minimal disturbance of the surrounding forest. And so you can sort of see that. We just cut lines through the forest, and if there were large and valuable native species, we left them. We certainly didn't cut them down. And again, the different zones. So all of our work is concentrated on about 1/3 of this property. The rest is being left, a lot of steep slopes up in these mountains, to see the natural regeneration of the secondary forest. And right now, by the way, I'm sure when I say the word Puerto Rico, you're thinking Hurricane Maria, which indeed really damaged our project. But because we have been trying to bring back a wood consciousness and wood industry to the island, they're really doing pioneering work, working with both Puerto Rican and FEMA organizations to save the hurricane-felled hardwoods, which otherwise would be chipped and put into landfills. So they have saved an enormous amount of the timber. They're still fighting the fight because vested interest and status quo is, we have a program to spend a lot of money and completely not value these hardwood trees. And then and we have Judy Hawes, the manager of October Gallery. Institute of Ecotechnics is a modern ecological perspective. And I think, traditionally colleges would go into Chicago and say, well, this is actually an oak hickory biome, and kind of ignore that it's been actually made into a multi-million person city. So cities, the world city is an anthropogenic biome, but ignoring it is folly, because actually what happens in cities drives a huge amount of what the impact of human technology on the planet is. So we decided to locate in the beautiful and vibrant city of London. And the October Gallery, which was started in the late 70s, took as its mission to be an art gallery with a big difference. It was going to basically search the world for cutting-edge artists from, I think, maybe 80 cultures have now shown at the October Gallery, and to get them out of the box of, oh, this is very nice, but isn't it ethnic art? No, these are cutting-edge artists. And largely, I think it's begun to change the art consciousness in the city. It's also a place as a view into some of the interior spaces and one of the exhibitions, a place where we wanted to have, and actually we'll get later to the Ledan Society, Royal Society. It's a meeting place also for artists and scientists. And that's been kind of our modus operandi from the beginning. Because I think it's really impoverishing to science, and it's impoverishing to artists to keep them separate. It's also unnatural, maybe inhumane. World ocean. Well, you can't really study the planet if you don't have a research ship. And being a pretty low income, very self-funded, largely institute, we decided to do a synergy of a Chinese junk, when the Chinese junks were ocean going, with a ferrocement hull and decks. And that was a great material when you have 20 or 30 unpaid institute people who can do the labor. Very strong synergetic property too, if you run into reefs, and that tends to happen when you do exploration in poorly charted waters. You send divers down to do an epoxy repair. And over its virtually 40 years of exploration, it's actually the 270,000 nautical miles. You can picture it as further than a trip from the Earth to the Moon. And it's done, including, by the urging of Sir Ian and Richard Evans Schultes, 2 years in the Amazon doing ethnobotany and many, many expeditions. And also the Mediterranean biome. And, this Mediterranean one is a really challenging ecology. This is just outside Aix-en-Provence. And these beautiful mini ecologies, the French have their little woodlands so they can shoot pigeons and whatnot, is under threat just by suburban development and land prices going up. So we made it the conference center, but also there's an occasion for me to tell you that the other major anthropogenic biome is agriculture and ranching. And it occupies a surprising amount of the Earth's surface. And what we do on farms and ranches is a really big part of the story. And Serena was mentioning, we first met, I believe, at the Planet Earth conference. But starting in about 1974, we started to hold these conferences. This is the last one we had, which is on the Mediterranean in Aix-en-Provence. But it was a place both to educate the Institute and to kind of network and bring together people at the top of their fields from many cultures and many scientific disciplines and artists and thinkers. And through that process, we actually it was also, let me be frank, it was an opportunity to meet our heroes.
Yeah.
And we found that, no honorariums, economy travel, people at the top of their field really want to meet other people at the top of the field and kind of like cross-pollinate, I guess would be the botanical image. And just one out of many, one of our heroes is Bucky Fuller. This is the 1982 Planet Earth conference, and he's next to Bill Dempster, who he did, for example, the lungs that Surian was talking about. He was a system engineer at Biosphere 2. And Bucky was, extremely generous. So, we built domes in several of our projects and then domes over those lungs. But we, through these conferences, we had the network of people because Biosphere 2 was on a much larger scale than any of the previous, these ecotechnic projects. And let me just, to introduce Biosphere 2, what tended to get the play in the media was, this is a space colony. Now, it is true that that was part of our thinking, but, we're kind of realistic people. You're not going to launch Biosphere 2 in spaceships anytime soon. We're going to start with the much more simple systems that the space agencies are working with, hydroponics, etc. But our contention was if, humanity with Earth life, the really wonderful thing when you get into biospheres is that humans come in biospheric envelopes. You can't really separate a human from a biosphere long. And it's extremely expensive, what we do in space right now. But our contention was that if we're going to actually have a future, a destiny in space, we're going to learn how to miniaturize the essential functions of the biosphere. But Biosphere 2 is much more than that. It was partly influenced, when we were kind of conceiving of Biosphere 2, comparative planetology. I hope that's not a foreign concept to you. Is now really driving a lot of astrogeology. We're learning about the Earth because we're learning more about, why Venus is different, why Mars is different. And now, of course, we're starting to find exoplanets. So our contention was, since we are making an uncontrolled kind of testing to destruction of our global biosphere, we need to start a new discipline, a new type of science called biospherics, comparative biospheres. And I kind of alluded to the fact that we have large ambitions. So we named Biosphere 2 Biosphere 2 to invite the question, where is Biosphere 1? Is that something else that you built that didn't work so well? No, Biosphere 1 is the one and only at the present moment biosphere we know. And we very much envision, and the Fat Lady hasn't sung, and I think the rationale for Biosphere 2 becomes more and more understandable as we progress into the 21st century, is there should be Biosphere 3, 4, 5, 10, 20, and they can be made with different configurations of biomes. The Russians, who we really cooperated heavily with and shared their experience, they were the leaders in bioregenerative life support. They wanted to do one in Russia, and Biosphere 2 we tried to make as clean and non-polluted as possible. They said, no, we'll make, Biosphere 3 in Russia will be highly polluted, and it will be a laboratory where we can study biogenic ways or phyto cleansing ways of cleaning up air, water, soil pollution. So to be used in many ways. So homage to, here's some of the science history that we tapped into. Vladimir Vernadsky, who still should be way more known, it should be up on these walls in my opinion. He was the Russian who really, he didn't coin the word biosphere, but he really revolutionized the understanding of it. He started the field of biogeochemistry, because as he went around, he started to see the power of life. Life is not just a passenger. Life has transformed the Earth. The Earth that we know is certainly a cosmic phenomena. There's certainly powerful geology, but the impact of life in making our planet more habitable, and the ever constant of life is to multiply, to conquer, and evolve species that can utilize more matter and spread over the Earth. And the other pioneer who became an advisor to Biosphere 2 is Claire Folsom. And back in the late 50s, he was the first, and then there was a handful of other people who started working with laboratory-sized closed systems. And to his surprise, he was a microbiologist, among other things, was his discovery that if he started with sufficient diversity and allowed some external light for photosynthesis and control of heat, that these systems would be indefinitely surviving, persisting, even changing. So some of his earliest flasks from the early 60s are still going strong. So closed ecological systems. So in Biosphere 2, you kind of get the picture. We understood we needed to have a series of biomes, including a micro city, the human habitat, and a farm. But once you make something highly sealed, then you start to think in different ways. I should also mention, and Sir Ian made very valuably, what the media tended to forget was this was a giant leap into the unknown. This was, in a way, making a new laboratory. We want to study global ecology, both at several levels of complexity, from the really detailed reductionist type of studies to larger ones. But we actually want to make an experimental facility and set up an experiment. And so there was some allegations or whatever that this was hubris, that Biosphere 2 is an example that humans want to control everything. Well, really quite the opposite, and especially I speak from the 2 years of living in there. We were quite cognizant, and all of the ecologists, we call them the captains of the biomes. Ecologists understand. You can set up conditions that are good for life, but you cannot control life, and there was no intention of doing that. That was one reason that we had such diversity of soils and types of water, is to maximize microbial life at every level of life as a safety factor. And maybe our first battle with the engineers is they looked at the designs of our architects and said, this is really going to be difficult, and we can save a lot of money if we just make a big box store. I don't know if you have Walmart here, but you have Marks and Spence, etc. Fortunately, the architects and the project managers held their ground and said, if we're Looney Tunes enough to think that we can make a mini biosphere, we're going to make something that is really awesome, that's really beautiful, because really what Biosphere 2 is, in one sense, an homage to our global biosphere. I mean, one of our scientists, Tony Burgess, who is the desert captain, has called Biosphere 2 a cathedral to Gaia. And I like that image because there's a lot of reverence when you deal with life systems. And from the H.T. Odom, who helped me with my PhD, he was the father of ecological engineering. He loved emphasizing that the history of evolution, the history of ecology, is basically ecological self-organization and manifesting under challenging conditions. So Biosphere 2 could also be seen as the greatest experiment in ecological self-organization. This is kind of interesting. So as I was mentioning, we made a big alliance with the leading Soviet institutes in Moscow and Siberia, who had done the pioneering work in human closures and a simplified ecology. And when they visited Biosphere 2, they totally got what we were doing, and they really liked it because they were dealing with simpler closed systems, and they could see, because we were versed in Vernadsky, that in a way Biosphere 2 is taking closed systems to a Vernadskyian, a biospheric level. But they said, you've named it wrong. It's not Biosphere 2, it's Noosphere 1. And how many people have heard of Noosphere? Okay. Not surprising. As I say, Vernadsky's work is, he's super renowned, like Darwin and Wallace in Eastern Europe and in Russia. Vernadsky was wise enough and understood the dynamics of the biosphere to see that the conflict, and it was the Vernadsky school that came up with the term technosphere to describe all of the human economic and technological developments, that the technosphere was doing damage to the biosphere, and he thought the next stage in our collective evolution was the development of the noosphere. Noos comes from the Greek for mind or intelligence. And he was saying we are, humanity is such a geologic force on the planet that we've got to regulate and make sure that our actions don't harm the biospheric system. So that's what noosphere means, and it was very profound for us because, as I was saying, once you actually envision an essentially materially sealed system, then that changes your thinking about what's tolerable. So our engineers, this was maybe the second revolt of the engineers, we're going to be asking you to do near impossible things, but there's a basic requirement. Nothing that you suggest, materials, machinery, equipment, that goes into Biosphere 2 can release pollutants that the biosphere can't handle. So we redesigned the technosphere and further said, you're not number one here. Number one is all the life systems in Biosphere 2. The technosphere's role in Biosphere 2 is only to enhance and support life functions. Because you're making a artificial biosphere, then you have to create winds and water circulation. You have to create waves in the ocean. We're excluding a lot of the natural functions of the earth. And I think this is maybe, Biosphere 2 perhaps, earned its legacy just in the demonstration that top engineers could get on the program and redesign a technosphere that is really fully compatible with the biosphere. And so, one of the other goals, and we anticipated, if you make a really tightly sealed system, you're probably going to be inventing or rediscovering and refurbishing eco-technologies of value. And one of our dread concerns was, if this is so tightly sealed, we're going to have the world's worst sick building syndrome because trace gases are going to build up. And we found a technology that's more used and known in Germany and elsewhere in Europe than in the United States, called soil biofiltration. And the idea that, like sewage treatment plants or engineers with nasty smelling factories, they had the out-of-the-box idea, let's put our exhaust air from that factory through the soil. And lo and behold, the microbes in the soil, they look at a pollutant and say,
Yummy.
oh, yummy, okay. I thought you were giving me a signal like 5 minutes or something. That's why I have a clock here. And we are going to leave time, inshallah, for questions and discussion. Yeah, so they discovered that the microbes, whatever the pollutant are, whatever the trace gases are, there's a type of microbes in general, there's one exception we could get to in discussion, that can eat it. So we developed this system. We actually made the entire farm, the half-acre, fifth of a hectare farm, engineered to be a soil bed reactor, a soil biofilter, because we could pump all of the air up through that soil in 24 hours if we had trace gas buildup. And one of our first design spin-offs is that looks like an ordinary landscape plant in an office, but in fact it's a soil biofilter, and the second chamber near the ground has an air filter so that all the internal air can be pushed up through it. So we have computers here. Humans emit trace gases, virtually all life does, certainly all human-made materials and machines. And the beautiful thing about a soil biofilter is you don't have to program it. You know, depending on what is in the air, a corresponding group of microbes will feast on it. And we've already been on this topic, so, you know, just to give us some bona fides, you know, the eco-design of Biosphere 2, you know, was looking at lots of complexity, and all of the biome captains who, you know, I have to say, you know, Sir Ian took on the challenge, but everyone knew it was completely unknown, pretty much, how many species would be lost. So the general strategy was species packing, so that hopefully after Biosphere 2 settled down and, you know, waves of losses, that we would keep food webs, because Biosphere 2 is not a botanic garden. It's basically a living micro-earth, so we need food webs to support all the life that we're putting in there. And just a little visual tour. So, you know, some of the surprises of the 2 years was just how much life like Biosphere 2. We, you know, by logistical necessity, we started with a small one, and plants grew amazingly. This is Sir Ian and his wife and John Allen and myself visiting the rainforest. And the rainforest, you know, one of the great strategies was fast-growing first canopy trees. And so we had Cecropia, but we also had Lucina, and these Lucina trees grew from 5 to, let's say, 2 to 3 meters to 10 meters. In the first 2 years, we actually cut and took them out because, you know, this part of the value of the rainforest biome in particular was strategies when the rainforest gets cut or chopped into pieces, how to protect both from harsh overhead light and side light. The savanna, which included a little billabong stream and vast areas. So I should say one of the wonderful things, which is explained at longer length or greater length in pushing our limits, was the humans had unique roles. We were the keystone predators. We didn't have herds of animals to graze the savanna. So we would intervene basically to defend biodiversity in our systems. We'll get to this later. We were also the atmospheric stewards, you know, trying to manage the very small atmosphere inside. Ocean with a living reef, and one of the most amazing systems I totally fell in love with, marsh mangrove biome. We took an estuary system from the Everglades that might be 10 or 20 miles long and compressed it into 7 zones in about 60 or 70 meters. And the desert biome. And this was okay, we'll go to the farm. The farm, and you know, the anthropogenic farm. So I've done a lot of organic farming in my life. It was really interesting. In closed systems, even some of the pesticides and control chemicals that are approved organically, we couldn't use because we intended Biosphere 2 to be a 100-year experiment. So anything at even small quantities that would build up in the water and the soil, the air, you know, was a no-no. And Biosphere 2 kind of exemplifies the ecological intensification that I think is the 21st century better answer than the Green Revolution. So what's now becoming current in the global biosphere is we need to have farms and ranches that retain their nutrients, because nutrient runoff from those activities are one of the leading pollutants on the planet. And the great thing about Biosphere 2 was it was such a compact and concentrated life system that cycles, the same cycles as why it's a global ecology laboratory, all those lovely, the carbon cycle, the water cycle, nutrient cycles are operating, but they're at far greater paces. So, for example, in Earth's biosphere, 3 years is the average time that a CO2 molecule stays in the atmosphere. 1 to 4 days in Biosphere 2. That means in 1 year we have 90 cycles. So as a laboratory, it was both challenging to manage and a storehouse of learning. So it was called a cyclotron for the life sciences by John Allen, and it's a wonderful metaphor, but it's actually kind of true. And so we would see fluctuations of CO2 of 500 to 700 parts per million, because unlike our biosphere, all of Biosphere 2 is illuminated during the day, so photosynthesis ruled, and at night, no photosynthesis, respiration. The great surprise, and I totally endorse what Sir Ian was saying, you learn more. If we knew everything that we needed to know about how biospheres operate, what a waste of time and energy and money to make Biosphere 2. We built it so we would find out what we don't know and what would be unexpected. So oxygen declined. And in all the meetings where we asked people their nightmares, no one ever said, you might start losing your oxygen. And furthermore, it was mysterious, because we couldn't figure out. This is when Columbia University, who later on came to management, who got involved. And okay, let's go to biomes self-organize rapidly. This is the first one. Biomass more than doubled during the 2 years. The fog desert began to transition to a more chaparral because we couldn't keep it as dry and couldn't control the seasons as well as a natural fog desert. And we decided to let it go that way. The biosphere was teaching us. And some of the Biosphere 2 biomes, and many of them, like the marsh and coral reef, and you're going to put a rainforest in southern Arizona. A lot of people thought that, in fact, we couldn't make these things work, or they would homogenize into the equivalent of an urban weed-dominated system. But I think they underestimated, one, the genius of our ecological designers and the power of the environmental technologies supporting different conditions. The Biosphere 2 coral reef, we knew that was going to be the most challenging, required weeding, tender loving care, chemical buffering during the 2 years. And Columbia University used it for some still widely cited landmark papers because they started manipulating CO2 after Biosphere 2 ceased to be a closed system. And those are, they were kind of harbingers of what's happening in our coral reef, our global coral reef. And then I have to talk about the personal experience. So learning to be a biospherian, and I did have a taste of this. We have a test module, and I went into our test module for 24 hours, and it was such a profound experience, in a really small enclosure. You immediately get that you're connected. Every breath, you're connected with this system. And you look around, you can see the plants. So in Biosphere 2, we also said all of these green plants, and the ones that we can't quite see in the ocean, they're a third lung. And what's really interesting about the biospherian experience is that, and as I've been telling you, I've been involved in ecology. I hate the word environment, but that's for another time. But it was always in my head. And the really dramatic thing that started to happen in the test module and became more and more profound, living with a small world that you're in this kind of communion with, the metabolic dance, the symphony of the biosphere, is that knowledge goes down into your body. And so, we didn't have to tell the biospherians to be careful, I don't think a plant was unintentionally stepped on during our 2 years. We understood, it became synonymous. The biosphere's health, this mini biosphere and our health, it's the same thing. If this biosphere gets ill, we're in trouble. So, and I think, I should say, educational outreach was really important. And at the time of Biosphere 2, the word biosphere mostly had to be spelled to people. It was not in common parlance. Sustainability, forget it, maybe a few academics were talking about it. and how the world has changed. So Biosphere 2, we didn't know it was going to be a big media and worldwide news event. But we were glad when it happened, and it's kind of like somehow Biosphere 2 touched a nerve. And I think it was a very prophetic experiment, a very inherently optimistic one, that humans, technology, anthropogenic biomes can be made. We're going to find out what we don't know and what needs to be improved, can be made to mesh with a living system. So they tell me that over 1 billion people watched the re-entry of the 8 of us into the Earth's biosphere after 2 years. Little vignettes. Unlike the Right Stuff, our management said, you have a rare privilege to be a biospherian. But I don't think we needed that encouragement to celebrate it in poetry, in art, in music, in documentary films. And then we had a great pleasure, that's the top right-hand side slide for you. That's one of our inter-biospheric arts festivals, where we linked up, with the technology of the early 90s with either artists, musicians, etc., on site or even to Los Angeles and other venues. And so we lived a very varied life, did huge amounts of research. We had a calorie-restricted diet. I should have said that farm was calculated by our agricultural advisors to be among the most productive half acres in the world without polluting the rest of the biosphere. But calorie-restricted diet was the science forte of our doctor, Roy Walford, inside. So we became the first humans to be studied in that. Oxygen declined, but we were not climbing a mountain. So we did a lot of physiological studies, and it kind of illustrates also that in biospheres you can decouple things that in the Earth's environment you may not be able to uncouple. And then the great pleasure of, I love that one picture of our plants getting into one of our air handlers. It's like a radiator, and it also produced winds. Because Biosphere 2 in some way was a progenitor of the Anthropocene, and life and technology really intimately meshed inside. And we had parties, we did our home brewing, etc. There's a picture of the Galago, and so we were mindful. We took a few bananas that Sir Ian and his team happily put into the rainforest, but we had to leave most of them for the Galagos to eat. And again, so one of the funnest things we did was reaching out to schools. They both came to Biosphere 2, and we linked up with, again, the technology available to us. And countless schools in the United States and around the world would have, and from grade school to middle school to universities, let's have an exercise, design a biosphere. And the great pleasure of trying to tell a 7-year-old, I know you really like elephants, but we can't really build a food chain that can support an elephant in a half acre. These kind of important learning experiences. And then the amazing thing of coming out and, with the first breath and the first look at the sky outside, it really reinforced to me that we had in fact been living in a different biosphere. The engineering was so good in Biosphere 2 that there was less than 1% air exchange between the two. And I have to show this slide because in 1996, this is two years after the second crew that had a closure experiment, we convened one of our meetings of closed ecological systems and biospherics. So in that picture, and Sir Ian spoke, but I'm sure he had pressing managerial duties or research duties at Kew. But anyway, we brought together, some of the leading scientists from Russia, from Japan, China, the Europeans, NASA, and the Biosphere Institute. And I'm so happy that there is that image of Wallace, because this is what two of the pioneers who've done the most advanced work in Siberia under the famous portrait of Darwin. So we would have had to got in the middle there, but it would have been a pleasure. And then, as Sir Ian was saying, I was in charge of the sewage system, and it was a great job because I could see it was kind of dazzling the people who were coming to see that here's this I'm Jewish, this crazy yid with a sickle, cutting vegetation. So we worked very closely with a NASA pioneer in this field. Our constructed wetland was treating all of the human waste, the laboratory workshop waste, the liquid waste from our domestic animals, and producing this beautiful ecology. It was a haven for ladybugs and a couple of our volunteer frogs. Also, if you have a frog in a system, it will find a wetland. And I totally fell in love with this technology because it was so elegant, and all of the remaining treated water and nutrients were being added to the irrigation supply. So again, 100-year experiment, we were very diligent about getting all the nutrients back into the soils that were producing our food. And I decided to go back to academia. So after doing my PhD at the University of Florida, I started a company, and I should acknowledge David Turchetto, who is part of the Wastewater Garden International team. And I think we kind of shook up the field because it's mostly dominated by engineers who just do reeds. No, I mean, I'm too ecological and they're so boring. I mean, monocultures are really boring. So we decided to make systems that would be irresistibly beautiful so that people at hotels and businesses and homes and whatever would love to have these systems there. They're designed to where there's no odor. And so we've had the great pleasure of working in 14 countries. These are a few of the illustrative systems. And David is a key component. We have a very ambitious project called Eden in Iraq that's going to do a town, a marsh Arab town in southern Iraq, which has terrible sewage problems that are polluting the wetlands. So that's in the works when things calm down and we get a donor or two of funder. So I wrote a book, and you all know Dylan Thomas. So my original title for this book was Holy Shit. My publisher said, no, we're not going to publish anything with that four-letter word in it. But I was also thinking, it could have been titled My Adventures in the Shit Trade. And, so this will be, if you get this book, which I encourage you to do, Synergetic Press is the publisher, will be the funniest book that you ever read about shit. Because when you go around, people either don't know what's happening, and I think they're a little afraid to find out what's happening to their caca and doo-doo, or they'll just straight up lie to you, even government officials. So a great deal of the fun of being in the shit trade is seeing, kind of doing detective work as to what's happening and then coming up with innovative, low-tech solutions. And what really endears me about constructed wetlands, it connects people to what's happening with their waste. And it's such a beautiful solution, So at projects we put them in, we say, don't save going to the bathroom when you get back to the city. Use the restaurant's bathrooms because you will be feeding and making happy plants all around you. So we've continued in closed systems. This is at the Synergia Ranch facility. We built it, we call this the modular biosphere. I think it's also a great educational tool that universities should have. They should also have a mini biosphere. But this gave, and the size of that was, it would fit into the shuttled cargo bay. So it gave us a chance to work with high intensity lights and systems maybe more immediately relevant to space. And I continue, I chair a session at the International Coast Bar meetings. And so this is kind of a gathering of some of the leaders of various bioregenerative life support, including the Chinese. There's two, groups in China that are really, really advancing the field. So, both from my Biospherean experience, and I think one of the legacies of Biosphere 2, which I explore in the book, is what insights does that give to, we're in a pretty much a pickle. I'm a dogged optimist. I think optimism is a yoga. You should never give in to despair. Because in Biosphere 2 we learned also things, cycles went so fast that there were no anonymous actions and there was no small action. every action counts. And so, you know, a lot of the lessons, you know, the insights that we had and everybody had, it was a big project. Probably 200 people, 200 scientists, engineers were involved. That kind of insight, you know, needs to be translated to, as I say, we're running a very dangerous experiment, the sixth extinction, the Anthropocene. We need an injection of noospheric thinking, some intelligence. Another shameless plug. So this is available at the October Gallery, which is a very happening art gallery very close to Russell Square. And Judy Hawes, known as Chili, has brought 20 copies, so we will be selling them at the reception in the library afterward. And I guess I'll just end with the approaches of ecotechnics and biospherics can help us learn to be, and I think, not only sustainable, but actually regenerative. I think, you know, we're passing through the era of destruction, and I can foresee in the noosphere, in an intelligent Anthropocene, that one of our big priorities is to restore the health, diversity of the biosphere, and to really appreciate, you know, what I was saying about the relationship of the biospherians with the small biosphere. That's literally true of everyone, and even though there isn't a green plant, we're in a Linnaean society, there's not a green plant in the spring, but you know, we're breathing, and we are in metabolic connection with all the plants and all the animals and all the microbes of planet Earth. And acknowledging that fact, I think, will change our behavior, and it will also enrich our lives. Thank you.
We can have time for questions.
My question is that, given the fact that during different times ice age and so forth, you have variations in the ecology, such as the daylight hours were the same, the temperatures were different, things like that. Have you considered experimenting with alternative ecologies other than the ones based on the ones we find on the Earth now?
Well, I'm not sure about that, but I should have really emphasized, because we're in southern Arizona, which, you know, it gets below freezing minimally in the wintertime, but it's basically highly sunlight driven. So this is essentially a tropical biosphere. But for example, the Russians were going to do, you know, temperate systems. If one happened in northern latitudes or far southern ones, might be boreal forests and tundra. So, you know, so within the scope of comparative biospheres, in fact, that will deepen our knowledge to have different climatic regions. You know, the biomes of the Earth are manyfold.
Well, I was also thinking of redesigning the species mixture that you have to see whether there's other alternative things that would work.
Totally. I think we're just scratching the surface.
Yes, I think, though, one of the things in planning that we definitely did was over species it, put a lot more in, and say, let's see what survives, rather than try and have a list that we want those, and those. Let it work out naturally and be the competition. And so that was another interesting thing, to see what did survive at the end when you put them all together. And in the rainforest we used plants from different parts of the rainforest. They were not all South American, predominantly so, but not all. In, I think, the savanna, they were all from one biome, and the desert certainly was. But in all cases, all the biome captains tried to put it in and have a wonderful experiment and see what survives in all this that we put in.
Your comments about spending 24 hours in an isolation chamber reminded me of John Cage's experiment of spending 24 hours in an anechoic chamber, with not only no sound from outside, but no reflection of sound inside the space as well. And when he came out, he said to the person in charge, after a while I started to hear two very faint sounds. One was a very low sound and the other was a very high-pitched one. And the man said, yes, the low sound was the circulation of your blood, and the high sound was the operation of your central nervous system.
But I have to say, the test module was not a sensory deprivation chamber. It was the opposite. It was so packed. But the sound is really interesting. And so we had a bio band inside Biosphere 2, and it was really and they used ambient sound, and it was a really interesting mix of the whir of fans and engines, and we had the Old Man of the Sea was this tidal generator. Again, the ecologists, made the engineers come up with a non-destructive to the marine life system. So we had vacuum pumps that pumped up, I think it was 10,000 gallons and released it. And I remember Linda Lay thought that sounded like the sounding of a gray whale. I guess I'm more a literary type. To me, it was Ernest Hemingway and the Old Man of the Sea. But living in Biosphere 2 is this amazing blend of natural sound and technical sounds.
The only thing I would add is the title of your book and its repercussions. Given that, according to Martin Luther, money and excrement were the same thing, you should get very rich.
I have friends in Bali, and they said we can't translate. That was when the title was going to be Holy Shit, because it's a Hindu culture, and you can't even talk about this subject with Brahmins. It's considered inappropriate.
Since
Yeah.
since there are only eight of you in there, why did the CO2 start to increase, and how did you bring it back down? With all those plants, why did it suddenly increase?
Okay, I'll make the first answer to that. Well, we found out that humans are a tiny part of the biomass of Biosphere 2. No, it had nothing to do with human respiration. If we held our breaths, we wouldn't have really impacted. It was the fact that because we were thinking about the 100 years, and for example, the roof of the rainforest was 25 meters tall. So we anticipated, so we put in very extensive soil reservoirs and everywhere, including even the farm had 1 meter of soil. So it was an imbalance. Is a really good question because I didn't point that out. Basically, the oxygen decline was because there was a temporary, an early phase imbalance between respiration and photosynthesis. And 5 years after we came out, soil scientists studied the soils of Biosphere 2, and they had matured to where they were releasing far less CO2. And if anyone cares to know the answer of where the oxygen went, the oxygen was being respired primarily by the soil microbes. And that CO2 wasn't just going into the atmosphere, or we would have known it. It was being absorbed in the structural unsealed concrete or untreated concrete inside the biosphere. So maybe I should put more science in here. This was a great thing, is that it was a completely unexpected storage place for the oxygen. And so as the biomass of Biosphere 2 increased, even the second closure team, which was in there for about 7 months, they didn't have to inject oxygen, which we finally did for human health purposes. And that also refuted some scientists, especially the reductionist small scale, said this is not a great scientific laboratory because it's so large and complex that if something happens, you won't be able to find out. And so the whole oxygen story was really a blessing because we learned so much about it. certainly know how to design and more better balance these aspects. But they use fairly sophisticated isotope tracking to track out what was happening. We finally drilled into concrete that was poured inside Biosphere 2 and outside. And outside should be like that. Outside had lower CO2 because we had much higher levels of CO2. That carbonation reaction was happening faster. So it was really elegant that we actually figured it out in just a few months once we got scientists with sophisticated methods going.
Mark, here in London I have a garden, but I have only pots. I don't have soil because I have a basement. How did you control insects?
With difficulty and not always successfully.
Yes, we put insects in, and one of the things that did go wrong, the pollinators disappeared during the 2 years that I had hoped would help, and that was because these crazy ants that are around in Arizona got into it, and it got overrun by these ants. And they really dominated all other insects. So there were very few others than these ants. We learnt about that too. That was one of the other things that certainly I think it would have been impossible to stop the ants getting in the construction period.
Yeah.
Because we were not using poisons too, even then. So it wasn't really surprising that the ants got in, but certainly they were devastating in a way.
So, there was a 6-month period between the end of that first 2-year closure mission and the second one. And there was an opportunity to map and measure all the plants, making system improvements. So we grew 83% of our food the first 2 years. Second grew because we'd learned which species and where to plant different crops. They had 100%. And the other answer, and so our insect consultants were coming up with, with other animals that might control the crazy ants, etc. But our basic strategy is familiar, I think, to most people. Integrated pest management. We had praying mantises and ladybugs, other releases. We were able to do only safe sprays, like BT is a bacteria that controls larvae and those kind of insects, and soap sprays.
I learned a lot about integrated pest management in preparation for Biosphere 2. In fact, did some inquiries, where can I learn about this? So Linda, Lee and I went down to Disneyland, because there, in the pavilion there, they were really pioneering integrated pest management. And so Linda and I spent 2 days with the experts there and their entomologists. They had 2 entomologists on their staff there. And so that was part of my personal preparation and Linda's preparation for going in there about how to do this. And that became very useful when I was involved with an Eden project, because the Eden project is using integrated pest management, as is Kew now in some of its houses too.
You have a question?
Did all of you survive? Did you have to eject anybody?
No. Did
So,
this come up yesterday? Somebody was saying yesterday, you said 8 people went in, did 8 people come out? I think they were pretty changed people.
have any of them gone mad?
Subjectively, one of my crewmates has one of her chapters, Jane Pointer. What was it? Suffocating, that's the oxygen deprivation. Starving, which was the restricted, we were not starving. Restricted calories, but nutrient dense, and slowly going mad. And I didn't really dwell on this. Her book, there's 2 chapters on the human experience in this book, Pushing Our Limits. And I think, we knew that there would be group tension. This is really well known. And in fact, you know, when I speak to audiences, if it's an academic audience, I say, remember the most acrimonious faculty meeting that you've ever been in. But then, you know, just try to visualize that the doors are locked and presumably you have, you know, ways to eat and get oxygen, etc. It goes on for 2 years. So we knew that was going to be a problem. There was a power struggle on the outside that I think kind of upped the ante in, we had sort of 2 cliques of 4 people. But, you know, reflecting on it, and, you know, I've written an earlier book that we wrote as we were preparing to leave. It's really taken me 25 years. I'm still digesting that experience. And looking back, I mean, what was really remarkable was that, you know, we all, Aretha Franklin, we respected each other. Everybody was really dedicated to the success of Biosphere 2. And what usually happens, or very often happens in these group dynamic problems, is subconsciously people start to sabotage their supposed enemies, and they may even sabotage the endeavor. There's a term that I learned from the RGS people, explorer's cholera. So you have both cabin fever and you've got these other issues going. But because it was so clear to all of us that Biosphere 2 is our lifeboat, it was totally unthinkable that we would actually sabotage anyone else's research or cooperating research with outside scientists or damage the biosphere. And you know, so among the insights is, and this is starting to reawaken, when I talk to younger people, you know, they're much more on the page than us older ones. You know, we're in the same situation on planet Earth, you know, and we're starting to learn that there is no local pollution. What happens in any country affects our global biosphere. All these cycles unite us. And I should underline, because I don't think it came up, a biosphere is materially closed, energetically open, and our biosphere is run by the sun. As we both had generators for the electricity and some of the heating and cooling, but largely sunlight drove the biosphere, and informationally open. And we also thought that the informationally open would be kind of a dialogue, the data from Biosphere 2 and the data from our global biosphere. But the Earth, and I learned this, you know, after being involved in the project, planet Earth is far more tightly sealed than Biosphere 2 is. Get a little bit of cosmic debris and dust. We lose some lighter gases, but it's a tiny, tiny, tiny fraction of a percent. So essentially, and this I don't think we're coming to grips with, there's no way. This was one of our agricultural consultants, the chair of sustainable agriculture in Michigan State, came up with what's really great about Biosphere 2, and it's changing my thinking, is there's no way. You can't throw anything away. You can't make problems disappear by putting away. And of course, that rapidity of cycling of Biosphere 2 is even more dramatic, but that's true in the Earth. The Earth's biosphere, you know, is tightly sealed, and there is no way.
Has it led to us knowing any more about water? Because water obviously is a fundamental issue, and about its capture and has anything come to light through this process to make it more obvious that we have to store and we have to use water as a main concern?
Yeah, I mean,
all the arid parts of the world are now in the desert.
You know, when I started doing these wastewater gardens, as I call my constructed wetlands, one of the real motivating factor was conservation of water. You know, so we're not only throwing away all the nutrients in so-called wastewater, but we're also throwing away water that should be, you know, being put to the service of life. So very soon after I started, you know, the wastewater garden international, we have affiliates in a number of countries. We started to put a second system after the constructed wetland because you know, mostly the Reed engineer guys, they have a pipe, and to the nearest water body they dump now treated water, but it still has nutrients and fresh water, which, as you're pointing out, you know, I think it's really clear, and people are saying water is like oil. It's a finite resource, and it's really under jeopardy both by pollution and increasing population numbers, increasing industry. So water conservation, I've got a number of grants, for example in Australia, which is acutely aware of how arid the continent is, and the water conservation, that we could actually green communities, these Aboriginal communities we did a lot of projects in. That was an equal motivator to the human health problems of poor sewage treatment. David, you have? He's had a question.
Probably I'm wrong, but I remember that there were also chicken inside for your food. Yeah, but how many? How you decide how many chicken or other animals for food? Enough balance inside the biosphere.
Well, again, it's not a problem of the we could handle all their manure and urine with our both composting and wastewater. I should say we wanted to have kind of a normal-ish diet. So we had pigs, which didn't work out very well, chickens, and African pygmy goats for milk, a little bit of meat. But we largely ate a vegetarian diet. And I'm sure that in addition to the calorie restriction, you know, we came out thinner for sure. Incredible shrinking biospherians, but healthier. So we had, you know, milk and meat, but it was a very tiny proportion. Actually, I'm glad you mentioned peanut. We included peanuts heavily in our agriculture, and the agriculture was 40 different crops. So the other, you know, there was IPM, and it was also, we're not going to be dependent on 1 or 2 or 3 crops. We have different varieties, and we did have some failure. Soybeans and white potatoes fell to broad mites and other pests we couldn't control. But so we switched to sweet potatoes and taro and yucca and things like that. So
one more question, I think. We're getting on. Yes.
Just a quick one. Did you discover any particular plants in the 2 years of experiments that performed in a way that was unexpected? Was there a study that you continued?
Yeah, did we discover any plants
was there a particular plant that stood out in your captaincy that performed in a different way or unexpected?
Did any plants behave in an unexpected, peculiar way? Is really the question. I think not, but what was spectacular was their growth. It really succeeded. Mark referred to the Lucina trees that really shot up. And so I think what pleased me is when I went in after the biospheres came out, and I saw the huge, it looked like a rainforest. I think maybe one of the exceptional ones that I was proud of was the Phytolacca. It got quite large, didn't it?
Yeah, I would say yes, they had Q. I couldn't put my arms around the girth of that Phytolacca.
And so to achieve a tree that did that in the 2 years and a little bit before closure pleased me very much, because that is, we researched a lot what one could do that. So that there's the other interesting thing that Mark didn't touch on, and that is the carbon fertilization. If you increase CO2, there are a lot of experiments now going on carbon fertilization as we suffer increased CO2 in the atmosphere from climate change. And I'm actually involved with another experiment with Birmingham Institute of Forestry, where we're putting CO2 into 3 different areas of forest and controlling it by the air currents to keep the CO2 at measured levels. And the data is coming out from that if you get more carbon dioxide, it does increase growth to a certain level, and then it drops. And I think one of the things I would say is that they didn't reach the poisonous level to the plants of CO2, they probably got quite a good bit of CO2 fertilization in there that accounted for the splendid growth. The Tepuy, the mountain, we put in sort of plants that more or less belonged there, but it did get overrun by Ipomaea, by, you know how bindweeds are in your garden. Well, I regretted putting in something from the same family because it really did take over. When I saw it, when I went back, when it was run by Columbia University, I was there to try and help them how to control the bindweed. So that was one of the plants that I felt that maybe I shouldn't have put in.
It made excellent fodder for our goats and chickens and pigs, though. But yeah, I mean, what happened with the morning glory was just astounding. I kind of know it as a gardener. You have to be really careful with it. But it was poised to invade the savanna. And, you know, it felt like taking up electric cord. It was just astonishing what it would do. But it was palatable. I mean, either eaten or composted. And we had a molecule exchange. I did want to re-emphasize the new roles. And I think, you know, becoming atmospheric managers is incumbent on us. We're atmospheric mismanaging right now. So, you know, the roles that we played inside Biosphere 2, I think really have resonance. And defending biodiversity and restoring ecologies. Fortunately, there are all kinds of organizations and people involved in that.
I think the lady at the back had a question.
I did, and it was about the animals, in fact. So aside from the crazy ants and the domestic for food, you don't apparently there was a frog or two, but what was the animal species like? Clearly not as prevalent as it seems like it was a human and a plant and coral reef sort of biome you were creating, unless I missed.
Well, we were limited by several factors. One, the glass reduced a lot the light, and actually that also, CO2 fertilization and diminished light probably added some growth to the plants. But we had to build food webs. So the Galago, I think there was a picture of one, that was our largest mammal in the wilderness systems. And they were delightful. I mean, we didn't have pets in there, but it was really charming. You know, on a night watch, we took in turn. Occasionally a Galago would turn up and sit down next to you, and you know, we wouldn't have a conversation, but their presence. And they used to use the gallery forest in the savannah as their conduit from the rainforest down into other parts of the wilderness section of, and they would stop in the trees and be attentively watching us, you know, having dinner. And, you know, and delight on both sides. We had reproduction of Galagos inside. We also, group dynamics was manageable among the people, but we actually had to separate two of the female Galagos because it was kind of a alpha-beta situation. We finally had to build a cage and bring that Galago food, so there was drama there. Because of no UV, the biome captains, you know, had to exclude, for example, daytime lizards because the UV is partly how they survive and make needed nutrients in their bodies. So they were you know, all of our ecologists had to work under those constraints.
UV was a bit of a problem, and for pollinators too. And it's interesting, I've seen this difference because the Biosphere 2 was glass, and that excludes the UV. The Eden project is a plastic membrane that UV goes through, and that's been another very interesting. We've had someone working on that effect, students at the Eden project, the difference between the two. So the Kew Palm House excludes UV, but the Eden project allows it in, and that is causing quite a difference on the plants.
Yeah.
Yeah,
You done?
yeah. So I was just going to say that we've got the books lining upstairs in the library where tea and coffee will be served, and you can also buy books up there. I just wanted to say that our next event here is on the 20th of September. It's an evening meeting, and Professor Rebecca Kilner will be talking about life after death, the ecology and evolution of berry beetles. Our events program is out now, so you can pick one up on your way out. And we'll just end by thanking our speakers, Dr. Mark Nelson and Sir Ian Price. So thank you.